Hi there, welcome to this tutorial on calculating energy. This tutorial, it's like two questions, two different versions of the same question. And in this, we'll cover all sorts of things with energy. So conservation of energy, drawing energy bar charts, calculating energy, and calculating work. The first question is asking about a model airplane that's dropped off from some platform up high and ignoring air resistance. And the second question is including air resistance. So there's two different ways to look at it, two different things to practice. Before I start going into the solution, I think it'd be great if you could try these two questions yourself. So give it a shot, hit the pause button, and then when you're done, come back and see what my solution is. Okay, so to start off with, there's kind of two approaches to get started in these questions. You could just start with an equation of conservation of energy, which is always true. So you could start with something like this. And then you would analyze the question and decide which one of these apply, and then solve for the unknown. But you probably know that I prefer to start with the graphical bar charts, and that's what I'm going to do in this question. So I'll start with the LOL diagram. And in the system, I'm going to include the airplane and the Earth. So at the beginning, it says the plane is dropped, so there's no initial movement, so there's no kinetic energy, but it's above the ground, so there's some gravitational energy. And then it's asking, what is the speed of the airplane when it is 3.2 meters above the ground? So it still has gravitational, but obviously it's moving, so there'll be some kinetic as well. So from that, I can get my equation, my conservation of energy equation. And, you know, it's the same thing as the algebra. If you just started with this statement here, you would have canceled that out. You would say, no, there's nothing there, and there's nothing there. And you'd get the same thing. So it's just a different approach of how you want to get your equation. So from here, there's kind of two paths forward. You could just go straight into rewriting the equation with all the variables. So in other words, you could kind of do it this way. You could go, well, e.g. I is mghi, and that's equal to mghf plus 1/2 mvs squared. And this is good in the case where if you're trying to find one of the h's, or like one of the heights or one of the velocities, and you don't have a mass, this equation works out well because all the masses cancel. In fact, you wouldn't need to know the mass in order to find a height or velocity. However, I think if possible, a better approach is to solve for each one of these individually. I think it just makes a bit more intuitive sense. So that's what I'm going to do. So gravitational energy initial is mghi. So that's 3 kilograms, 9.8 meters per second squared, 6.5 meters. So that's 1.8. So I get 191.1 joules. And then for EGF, very similar. So 3, 9.8, 3.2, 94.08. And then I can take this equation and solve for EKF. So that's 191.1 minus 94.08. So the kinetic energy is 97.02 joules. So that means when the airplane is 3.2 meters above the ground, it still has 97.02 joules of kinetic energy, and it's asking us for the velocity. So 1/2 mvf squared equals 97.02. So that's 2 times 97.02 divided by 3, which is its mass, square root. And I get 8.04 meters per second. Okay, so that's the first question. And that's a really common type of question. Other questions, sometimes the thing starts with some kinetic energy, so there's another factor you have to keep in mind. But generally speaking, these questions are all pretty much like that. The second question is a little bit harder. It says, okay, we're going to include some air resistance. And we're not told how much energy it is, but we're told about a force. So I think whenever you see a question like that, and it's like force, that maybe kind of think about what that means in terms of work. Okay, so I'll start with my LOL diagram. And I'll keep the plane in there and the earth. And I know that work is force times distance, so I'm pretty sure I'm going to be using that relationship. Starts off at the same height as before, so we have some gravitational energy. We're analyzing it when it's just about to hit the ground, so there'll be no gravitational energy at the end, and there'll be kinetic energy. And we know that we could either say there's thermal energy lost, but in this question I'm going to treat it as work. So 1 block of work is coming out. So you can think of it as EG initial equals work plus EK final. Or the other thing to kind of think of is that idea that when work is leaving the system, it's a negative number. So we could still write it like this. But we're expecting this work to be a negative number. And in fact, is what's happening. If you did a force diagram of the plane, that's Earth on plane. There's air resistance on plane, air on plane. So that's up, but the movement is down. So when that force and direction in the opposite directions, it's a negative number. In this case, the work is, what is it? 4.6 newtons. Yeah. So it's 4.6 newtons times 6.5 meters. So that's 29.9 joules, and it's negative because it's pushing up but coming down. So we get, so we're going to keep that work as a negative. And the initial gravitational is the same as before, which was 191 joules. So we get EKF equals 191.1 plus negative 29.9. So that's 161.2 joules of kinetic energy, just as it's about to hit the ground. So similar to before, we have 1/2 mv squared equals that 161.2. So VF equals 2 times 161.2 divided by 3 kilograms, and then the square root of that, which gives us a final speed of 10.4 meters per second, just as it's about to hit the ground. So the work thing can get a little bit confusing. It's totally okay, really, to kind of do it this way, and keeping in mind that that would be 29.9 coming out of the system. That's the most important part. I was just trying to be consistent with this idea of that the work is negative because the force and the direction it's moving in opposite directions. But as long as you're keeping your bookkeeping clear, keeping track of your positives and negatives, you'll get the same answer. Anyways, I hope you found this tutorial helpful, and good luck in solving your energy questions.